Okay, open your books to chapter 13, section 1. We're going to start looking at right triangle trigonometry.
Right triangle trigonometry.
Yes.
Wow, that sounds really interesting. We
RTT.
couldn't have gone out. I'm so glad I'm not learning this.
Oh, I know.
All right. Shh. The first thing we need to know is a basic understanding of the parts of a right triangle and what they're called. What makes it a right triangle? It's a right triangle if it has a right angle in it, and a right angle is equal to 90 degrees. The side of the triangle that is opposite the 90-degree angle is always called the hypotenuse. The other two sides of the triangle are called the legs. Now this is important because whenever we deal with our trigonometric ratios, whenever it says something about a leg, we know that we're talking about one of these shorter sides. When it says the hypotenuse, we need to know what side it's talking about. Now, a prerequisite skill that we need to know before we even get into this is the Pythagorean theorem. And I'm sure y'all have all heard of the Pythagorean theorem before. Hopefully you've all used it already. How many of you in here have already had geometry? All right, so this should be reviewed because you did this in geometry already.
Yeah, but geometry was kind of.
But that teacher, she was too good of a teacher.
The Pythagorean theorem,
Are you keeping track of your 10-minute
no, I record the whole thing and then I have to create movies. Yeah. Okay. The Pythagorean theorem says that c squared is equal to a squared plus b squared, where c always represents the hypotenuse. It is the longest leg, or the longest, side of a right triangle. And the square of it is equal to the sum of the squares of the two legs. The Pythagorean theorem can only be used with right triangles. It cannot be used with acute triangles, which are three angles less than 90 degrees. It cannot be used with obtuse triangles either, only right triangles. And it can only be used if you know two of the three sides. Because if you only know one of the three sides, you're left with two variables. And you can't solve a single equation with two separate variables and get definite answers. So, it's limited, which is why we have our trig functions. Trig functions, like the Pythagorean theorem, can only be used with right triangles. Okay? So now that we have all this down, I want us to look at our 6 trig functions that we're going to be working with today. 6 trig functions. Okay? Let's erase this. We'll come back to it. There are 3 primary trig functions that we're going to be using, and the other 3 are just the inverse of them. And the inverse is when you take a fraction and flip it, right? Okay. So, the first 3, I want you to remember this expression. Soka toa. All right, think of it as a sentence. I always remember it like if I hit my toe and it's hurting and I got to soak it in salt water or something. I soak a toe, okay? But soka toa. These are acronyms. Hey, whatever works.
It sounds like an Indian would say that.
Yeah, well, whatever works.
Oh, man.
It works. Go soak your toe. All right.
No. Oh my gosh.
The letters are acronyms for the parts of the functions. Okay, the first one, SOH, refers to the sine function, and it is this. The sine of theta is equal to, O represents the opposite leg, and H represents, I can't spell hypotenuse today, there we go. The hypotenuse of your right triangle. Now, theta is the actual angle that you are referring to in the right triangle, and it's not going to be the right angle. It's going to be one of the other 2 angles. And we're going to get a lot more detailed and tell how to identify all these pieces, but right now we just need to get this down. S for sine, O for opposite, H for hypotenuse. Cos is cosine of theta is equal to the adjacent leg over the hypotenuse. Once again, theta is a Greek symbol representing the angle measure. And TOA is the tangent of theta, a degree measure, is equal to the opposite leg over the adjacent leg. Now the reason we have these three different ones is because it depends, which one we use depends on what parts of the triangle we know. Or what are we looking for? If I know an angle and I know the opposite leg and I'm looking for the adjacent leg, do either one of these help me? No, because this one has a relationship between the opposite leg, the angle, and the hypotenuse. But I don't need the hypotenuse, I need the adjacent leg. All right? Which one would I have to use to find my missing piece? If I know an angle, the opposite leg, and I'm looking for an adjacent leg? Tangent. Because that's the one that has the three pieces of the puzzle that I'm trying to fit together. And the problem I'm trying to solve. Okay. Now, like I said at the beginning, there are 6 trigonometric functions. The next 3 are simply the inverse of these 3. The inverse of sine is the cosecant function. Whereas the sine function says opposite over hypotenuse, the cosecant says hypotenuse over opposite. It's simply the reciprocal of the sine function. Where the cosine says adjacent over hypotenuse, the secant function is hypotenuse over adjacent. And where tangent says opposite over adjacent, cotangent says adjacent over opposite. All right, and you still have the thetas in there. I'm just running out of room. I'm trying to squeeze it all in on the video. If you know these 2 measures to find sine, you can also find cosecant. Because all you do is flip them to find the cosecant. So what is the inverse of the sine function? The cosecant function. Okay, now, when I was in school, I was like, okay, this is retarded. Why isn't the secant function the opposite of sine and the cosecant the opposite of cosine? I don't know, but it's not, okay? So you got to put that in your memory because you're going to get confused. Because your brain's going to want to stick your co with your co. Cosecant and cosine, but it's not that way. So we've simply got to memorize this. All right? Now, knowing all this stuff, what is the opposite leg? What is the hypotenuse? Not every right triangle has the same leg classified as the opposite leg. The opposite and adjacent legs are in reference to the angle measure that you are using to solve the problem. So what we're going to do is we're going to look at a right triangle, ABC. I am going to identify angle A as my theta angle, okay? And I'm going to put measures on these sides, all right? We'll say this is, it looks like an isosceles right triangle, but we'll pretend it's not. Legs of 4, 3, and a hypotenuse of 5. Okay. The sine of A, angle A, is equal to the opposite leg, opposite of what? Opposite of angle A. Well, if this is angle A, and I go straight across, which side?